Okay, so before we get started looking at some exact measures on the unit circle, let's do a quick little refresher of the unit circle, specifically talking about degree measures. So we know over here we have the point 1, 0. The reason it's called the unit circle is because we are 1 unit away from the origin. Okay, up here we're going to have the point 0, 1. To the left we have the point negative 1, 0. And then down here we have the point 0, negative 1. As far as degree measures go, we know that as we move counterclockwise, that's moving in a positive direction, versus moving clockwise takes us in a negative direction. And I'm always starting on the right positive x-axis and turning, okay? So 90 degrees starting here, going up 90 degrees would be right up here. Half of the circle over here would be 180 degrees. Down here would be 270 degrees. And then when I get back to where I started, that's going to be 360. It's also 0. Okay? Little review of degree measures. So, let's say we're asked to find the cosine of 240 degrees. Well, our first order of business is going to be to find out exactly where 240 degrees is. So I'm going to start over here, and I'm moving in the positive direction because this is positive 240. I know that half of the circle is 180, so I need another 60 degrees. So that's going to have me down in here with a 60-degree angle right here, because half of the circle from basically from here to here is going to be 180, and then I need a little bit more, 60 more degrees. So now, I know that when I'm asked to find a trigonometric value, I need to make a right triangle. But I always want to make my right triangles with my x-axis. So I'm going to go from this point here, and I'm going to go straight up to my x-axis, and back to the origin, put a 90-degree angle, and now I have myself a 30, 60, 90 right triangle. In order to find some side values, though, I need to know at least one of them. Well, remember that this is called the unit circle for a reason, because this is the point 1, 0. So this radius from the center of the circle to that point is a length of 1. At the same, for the same argument, any radius at all on this circle is going to be a value of 1. So if we look at our right triangle now, I do have a radius right here. That's a length of 1. Okay? Any radius in the circle, in the unit circle, is going to be a length of 1. Alright? So now I have this right triangle. In order to do cosine, I know that cosine, because of SOHCAHTOA, C-A-H, cosine is adjacent over hypotenuse. So I need those two sides. Well, I already know my hypotenuse. Cosine of 240 equals, I know my hypotenuse is 1. But I need to know this adjacent side. Now I want you to keep in mind, although I put the 30-degree angle in there, this 60-degree angle here, that's our reference angle. That's the one we're actually working with here. Alright, so I want the side that's adjacent to that. Well, there's a couple ways I can do this. One way is to use SOHCAHTOA. But the problem with that is, jump into your calculator, you're not going to get an exact value. In some cases you'll get an exact value, but some cases it's going to be a decimal that you're going to be forced around. So instead, let's use our 30, 60, 90 template. We just got done talking about these. Okay, so if this is my 60, alright, then I know that the side across from the 30, which would be this side, is my shortest side. And then the hypotenuse is going to be 2 times that shortest side. And the middle length side is always the shortest side times the square root of 3. Okay? So, here's the question. I'm given this. Okay, my hypotenuse is 1. if I want to go from my hypotenuse to my shortest side, what am I going to do? Well, I know that if I go from my shortest side to my hypotenuse, I'm going to multiply by 2. But I'm going from the longest to the shortest. I need to divide by 2. So if I do 1 divided by 2, that leaves this side right here. Let me do a quick little erase here of this angle that I had drawn in. This shortest side is going to be 1 divided by 2. Okay? Now here's the thing. Think about the fact that we're starting at the origin and we're going to the left. Okay? This is actually a negative 1/2. Alright? That's a negative 1/2. So my adjacent side now is a negative 1/2. Now, any number divided by 1 is just that number. Okay, so think about 8 divided by 1 is just 8. 10 divided by 1 is just 10. So if I do negative 1/2 divided by 1, well, it's just negative 1/2. And that's the value of the cosine of 240 degrees. Now, for the sake of just finishing up this unit circle, because we're going to need to do this soon, I also want to mention the fact that once you have your shortest side, to get your longest side, you just multiply by the square root of 3. So if I take my shortest side, which in this case is negative 1/2, and I multiply that by the square root of 3 over 1, I get the square root of 3 over 2. It's negative. So this side here is negative square root of 3 over 2. Alright? So if we think about this point on the unit circle right here, that point is negative 1/2, which is the amount that I went to the left, comma, negative radical 3 over 2, which is the amount that I went down. Now that is not necessary for this problem. You know, this is our answer. But for the sake of moving forward, we're going to need to find that for the unit circle. Okay. Pause it now if you have questions. Jot them down. Okay, let's do another one of these. The sine of negative 135. Let's start by finding negative 135. So if I start here, and remember my negative direction goes this way, negative 90 will be down here at the bottom. I need to go another 45 degrees. This angle here is negative 135. Now remember though, when I draw my right triangle, I always want my right triangle to go up to the x-axis, or down to the x-axis. So I'm going up here, over to here, back down. This is a 90. Okay. I also know that this is going to be a 45. Alright? Because I went down 90, I went another 45. I know there's 90 degrees in each quadrant. So basically that 90 gets split right in half. I know that my hypotenuse is 1. And when I'm doing sine, because of my good old friend SOHCAHTOA, I know sine is opposite over hypotenuse. Alright, well I have my hypotenuse. Sine of negative 135 is equal to, my hypotenuse is 1. I want to find opposite. Well, opposite of what? Opposite of that 45. So, let's think about our template for 45, 45, 90s. I'm going to kind of put it down here so it kind of coincides with the right triangle we're dealing with. Anytime I have a 45, 45, 90, that 5 got a little sloppy there, sorry about that. Both of these two sides are the same because it's an isosceles triangle. And the hypotenuse is always n radical 2. So I have the hypotenuse. I want to find this side. To go from n radical 2 to just n, I need to divide by radical 2. So I'm taking a hypotenuse of 1 and dividing it by radical 2. Now it's easy to go, oh, you know what? Okay, this is 1 over radical 2, this is 1 over radical 2. It's easy to want to do that. But remember, we cannot have a radical in the denominator. So we can't jump to the conclusion and write that quite yet. Okay? We need to rationalize the denominator. And you know how to do that because we just got done doing it. Let's multiply by radical 2 over radical 2. Square root 2 times square root 2 is 2. 1 times square root of 2 is just square root of 2. So now I can write each of these sides as radical 2 over 2. Alright, so my opposite is radical 2 over 2. And remember, like we just said in the last one, any number divided by 1 is just itself. So the sine of negative 135 is equal to, oh, I almost made a mistake there. I hope some of you were yelling at the screen saying, wait a minute. This needs to be negative radical 2 over 2 because I'm going to the left from the origin. This needs to be negative square root 2 over 2 because I'm going down. Okay, so this is really 1, this here is negative, this is negative. Negative radical 2 over 2 divided by 1 is just negative radical 2 over 2. That's the exact value for the sine of negative 135. Pause it now if you have questions, jot them down. One more to go. Alright, sine of 30. 30-degree angle. Starting here, positive goes this way, 30 degrees. 30. Okay, dropping down to my x-axis, right there. Hypotenuse is 1. So now what I need to do is take my 30, 60, 90 template, knowing that the side across from the 30 is always the shortest, hypotenuse is always the longest, middle side is n radical 3. Now if I'm doing sine, I know because of our good old friend SOHCAHTOA, I'm doing opposite over hypotenuse. If I'm going from my hypotenuse, which I have, is 1, to my shortest side, I'm dividing by 2. So 1 divided by 2, this side is 1/2. And then to go from my shortest side to my middle side, I'm multiplying by radical 3. So when I do 1/2 times radical 3 over 1, I get radical 3 over 2. So this side is radical 3 over 2. And those points are positive because I'm up in quadrant 1. Now that I have all three sides, and I don't even need all three sides, but it's like you're already in the process of doing it, you might as well just keep going. So I have sine of 30. Remember, this here is the angle I'm working with, so opposite of that is 1/2. So I have opposite, which is 1/2, over hypotenuse, which is 1. Any number divided by 1 is just itself, so we just leave this as 1/2. And that's it. So this is the last slide as far as doing these using degrees. One last point. Remember this point out here on the unit circle? That's going to be an x value of radical 3 over 2 and a y value of 1/2. To the right, radical 3 over 2 and then up 1/2.